Hi everyone, welcome to this first webinar by Virtually Surge. I'm very pleased to have all of you with us today. I'm Olivier Fontaine, I'm a head of operation of Virtually Surge, and I'll be the moderator of today's session. So I'll start to share my screen. Hope you can see it now. So the topic of today is going to be how to overcome barriers and keep training a healthcare professional with a hands-on virtual reality solution. And to do that, we have the chance to have three key speakers with us today that are going to give us their strategic insights on the pedagogic, the clinical, and the industrial words. So maybe I'll let each speaker introduce themselves in 3 seconds while we wait for everyone to connect to this webinar. So I let the floor to Anna. Anna, are you here?
Yes, I'm here. So yes, thank you, Olivier. And first of all, it's a great pleasure to be here today and talk a little bit about our research here. And so my background is in cognitive psychology. I'm a postdoctoral researcher at the Stanford University now, both at the Graduate School of Education at the Virtual Human Interaction Lab, where I'm in charge of the educational projects using virtual reality for training and education. My research focuses on the cognitive and affective aspects of learning and how we can use VR to enhance training and education. I'm also a Chief Learning Officer at the Virtual Research, where I'm in charge of the pedagogical and psychological aspects of the VR experiences that we are developing.
Thank you, Anna, and thank you for the very early meeting for you. I'm now also with Dr. Nicolas Penet. Nicolas, I'll let you introduce yourself.
Hi everyone, I'm very happy to be here. I'm Nicolas Penet and I'm a spine surgeon in Lariboisière University Hospital, University of Paris. I've been interested and I've been working in virtual reality and simulation in surgery and more particularly in neurosurgery and spine surgery. And I'll try to show you important aspects on the pedagogical strategies and why it's very important to implement in a university center and healthcare system simulation and virtual reality.
Thank you, Nicolas. And so we have also another Nicolas with us, Nicolas Mignon.
Yes, hello everybody. My name is Nicolas Mignon. I'm the CEO and the co-founder of Virtual Research. Before I managed French University. And I'm very proud to be with Hannah and Nicolas to organize this webinar for you.
Thank you to all of you. So maybe just before we start and to warm up the audience, I'm going to launch a very quick poll to better understand your interest for this webinar. I'm just trying to. Sorry.
I open for you, Olivier.
You launch the poll? Okay, so you have 10 seconds to give us your insights into your main interest for registering to this webinar, and it will give us interesting insights for the discussion after the presentation. And of course, I'm going to tell you the results in a few seconds. So I'll just let everyone complete. Okay, so now we have 2/3 of the audience who have registered. So so 1/4 of the audience is naive in the field of virtual reality and wants to know more. 1/3 knows VR but is interested about the hands-on approach, and 42% have a concrete project in mind, which for sure will give us very interesting discussion at the end of the webinar. Thank you for sharing with us your insights. So now we will start with the first presentation of Anna, who will explain us the the pedagogical power of virtual reality overall. Anna, the floor is yours.
Thank you, Olivier. So when we talk about virtual reality, and it's good to see that a part of the audience already knows what it is, but I always like to start explaining a little bit what is virtual reality and what are the other kinds of immersive technologies that we can use. So Olivier, can you share my screen, please?
I thought it was shared.
Yeah, my slides, yes. Thank you. So exactly this one. So this is, can you just go back one? Thank you. So this is the Milgram Continuum that we say. And we have on the left side, we have what is real. And on the right side, we have what is completely virtual. And when we have our real environment and just one layer of digital content over it, that's what we call augmented reality. And then we have some glasses as Google glasses. Many years ago, we have the Apple glasses that's about to be released. That's an example of augmented reality. We have also devices that they can add this digital layer to this real environment and allows you to interact with it. That's when we say it's a mixed reality. And for example, we have the Microsoft HoloLens as an example of a mixed reality headset. And we have, when we are most on the right side, immersed in this virtual content, we call this virtual reality. And those headsets, they block any kind of stimuli coming from the outside world and let you inside this digital content all the time, where you can interact either using hand controllers, haptics, or even your hands. So most of the research that I conducted at Stanford, we used virtual reality headsets. And always, this is a very good question that I always have is why we should use VR if we have so many other media, if we have so many other technologies and methodologies that we could use. And my answer is we always say VR for situations that requires a very special feature that VR can give us that's called immersion and presence. So immersion is when you are immersed in this digital content, and VR is perfect for that because it's blocking any kind of stimuli coming from the outside. And when you are in this digital environment, you feel that you are inside there. So it's what we call presence. Your brain understands this digital content as real and responds as it. So for example, we have this experience at the Virtual Human Interaction Lab where you need to cross this pit. And we have that 1/3 of the participants, they just don't want to do that in VR. They just take the VR headset out and say that they are afraid. If we could measure their heartbeat, it would be higher than before putting the headset on. If we could see their hands, sometimes it's sweating. So it's their brain saying that they are in this virtual environment for real. So that's the power of VR, and we should save using VR for those situations that we need this kind of response from our body. So those situations that we save VR for is, for example, dangerous situations. So here in California, we have a lot of earthquakes. So it's much more safer to train how to behave in a case of earthquake beforehand using VR than in the case of a real earthquake. Situations that would be impossible. So for example, so far we can't fly, but if I want to understand how flying would change my behavior, then I can use VR for that. Situations that would be counterproductive. So if I want to investigate how much cutting down trees would impact people's behavior of consuming paper, their pro-environmental behavior, it doesn't make sense to take them to a forest and cut down trees. So I can do that in VR, and we have some research about that. And situations that would be expensive. So if I want to learn about the ocean and the biodiversity of the coral reefs, I would love to take all the students to the ocean and dive and learn about it, but it's too expensive. So I can do that bringing a headset to the classroom and they can experience that. So those are the main situations that we save VR for, and that VR is very powerful too. And when we check the literature and we see the companies that are now working with VR, what we see that's most popular uses of VR are for sports training, retail training, medical training, very popular and successful. And we have for education, K-12 education, higher education, and also for pro-environmental behavior. Then next one. But when we check those applications and research, what we see in terms of learning is that there are so many different results. Some studies showing that VR is not effective as a computer, for example. Some studies showing that they are the same, and some studies showing that VR is better than other media for learning different tasks. So if we go deep on that, and that's what I did doing my PhD, we can find that. If we check what kind of tasks, yeah, the next one, is involved on each of these applications, we would see that for sports, for retail, and for medical, we have procedural tasks. It means that you need to memorize some steps to do well on that task, that you need to repeat something. And very often you need to move around. You need to be able to interact with the content, interact with something that you need to memorize. In those applications, VR has been proven to be very, very effective. For conceptual knowledge that we call, we can see that K-12 education, higher education, and pro-environmental behavior, we are talking a lot about learning new concepts. So we need to integrate that information with what we already have. And this is the gray area. So it depends more on the design of the experience. It needs to be really well designed to be successful in those cases. So then, yes. And when we talk about surgical training, what are the features that surgical training has? So we can see that surgical training, it is dangerous. You won't train in a real surgery. You need to be training beforehand. It would be counterproductive if you only have training during procedures. It would be very expensive, and it is very expensive to keep all the infrastructure needed to train for surgical training, for surgical procedures. And it's a procedural task. It means that you need to memorize steps, you need to interact with it, you need to know exactly how to move and what to do on that procedure. So that's the perfect, what we call the perfect use case for virtual reality, because it unites all these special features that VR can address and work with. And that's why we are not surprised to see that when we talk about the VR market, there are very good projections for the next years. The market is improving, and the most cause of this increase on VR market, both on the headsets and the content development, is healthcare that's pushing the market for virtual reality. So that's what I brought for you today. Thank you. And now Nicolas will keep the presentation.
Thank you very much, Anna, for sharing this overall insights and framework on the power of virtual reality, and for making this very nice transition to the field of surgery. So now I will let Nicolas Penet deep dive more into the specificities of surgery and why simulation, and especially VR simulation, is of key importance in this field.
Yeah, thank you, Anna. It was a very interesting presentation. So I'm Nicolas Penet. I'm very interested in VR and simulation, and I'm a spine surgeon in a neurosurgery service. And I will try to highlight the important points of why the substratum of implementing simulation and VR within university centers and within a healthcare system. You know, there is an actual shift of paradigm in the surgical strategies of teaching. The former model, I would say, was see one, do one, teach one. And that's the way I was trained myself. And this implies a very fast transition from the state of observer to doer on an actual patient. and it's based on a relationship between master and apprentice, and you should watch and emulate what the expert senior surgeon is showing you and trying to apprehend the very important notions. There's a very strong notion of surgical exposition. There's a 10,000 hours paradigm saying that you need to give your life to surgery for one and be able to manage and face every kind of situation because you've been exposed before in your past experience. That was applicable, that was used in former healthcare system models, which are, as Anna said, changing and pushing for new kind of teaching. There's a gap between conceptual masterizing of a procedure, a surgical procedure, and the technical proficiency of the training. And this gap needs to be bridged, and that's why we are talking about right now. To become an expert surgeon, there are 6 main skills to develop, to apprehend, to avoid complication, and to fulfill the task that is asked to the surgeon. There is the technical point of view, which is actually see one, do one, touch and teach one within your way of teaching, saying that you need to focus psychomotor skills on a very single procedures. This is sustained by a very strong theoretical formation. You need to be very good in anatomy, to good in radiology, and you need to keep on learning and to get in touch with the scientific literature all your life long and all your day long. But to be very performant, you need to link cognitive skills to technical skills to apprehend what you're doing and what is the consequence of your gesture, the acts that you're actually doing in the OR. That implies as well to know actually when to operate and overall how to modify the initial plan of surgery upon the clinical elements that you're facing in the OR. That's what's very important. To become a good surgeon, you need as well to develop soft skills, to be able to communicate with the rest of the team, anesthesiologists, to have a strong ethical and honest personality. You need to have physical skills that you might develop in your residency, be able to endure long hours in the OR and have the stamina to get through that. But the most overall the most important aspect is experience, as a C1, do one, teach one, and 10,000 hours paradigm are sporting. But you need to be exposed to different kind of anatomical diversity, pathologies diversity, and variation of morphology of the patient. And that's what VR is able to do. Whereas when you're in the actual OR, you're not limited, but it's not expandable to the infinite. What is changing in 2020? There are medical legal aspects. There is a quite strong restriction of doctors' hours, duty hours. Trainees are not allowed to remain in the OR for a day, night, weeks in a row. And there is, as a consequence, a lack of surgical exposition. On another side, healthcare systems are trying to meet quality insurance targets to avoid complication and to reduce surgical time, leaving much less time to teaching and other stuff. They need as well to have an optimized OR. The efficiency of the OR needs to be increased, and that's a very strong point. On another side, to the trainee is asked an increasing, a very large repertoire of procedures, and to be able to face, at least at the beginning of the residency, quite a lot of pathology to apprehend the specialty. Along with that, there is an ultra specialization. When you become a surgeon, the chief resident, you're going to say, okay, I'm a neurosurgeon, but I'm going to be a spine surgeon, I'm going to be a vascular surgeon. And it's very important to be ultra specialized. And that's where VR getting in very strong into deep thematics gets you to become better and stronger. But with the old model, there's a lack for mixing all the skills that a surgeon needs and a lack of adaptation to new healthcare system. That's why we need a competency-based surgical education, including different sequential modules that needs to lead the surgeon, the trainee, to meet objective learnings in order to access to the OR. In this slide, we try to show you the different learning curve that we have with these two teaching models, which are simplified. In the C1, do one, teach one, you're actually in a danger zone before you're an expert surgeon, or at least able to proceed to a strategy. In this danger zone, there are ethical problems, legal problems, financial problems for the healthcare system. Whereas where you are on a competency-based teaching strategy, you use a simulation to make the first mistake in the simulation, and you have the right to access the OR when you have met the learning objectives. And then you do one. Once you've already trained, you have already made your mistake, and you are able to proceed to the procedure, to do it properly. There are many studies supporting those few items that I've been trying to show you, saying, for instance, that restriction of duty hours has not led to increasing optimization of the healthcare system and on the quality of life of the trainees. Up to 50% of the residents say that they feel a lack of confidence arriving to the OR as a first operator. We need to fill that gap. There are a few studies, quite a lot of studies actually, showing that there is a strong impact on surgical skills with a simulation, with significant results. On the other side, and to give reliability on the VR, they have been correlating very well experience to results on the VR. So expert surgeons have good results on simulators, and it gives quite a good reliability to simulation. On the cognitive aspects, teaching cognitive skills brings better results versus teaching without cognitive skills. So when you know why you do a gesture, when you try to avoid a complication, you have better outcomes, and you have a gain of efficiency in the OR. So that's a pretty strong point. And finally, for example, in neurosurgery, simulation over physic models such as cadaver, which is actually a kind of a simulation, and physical models versus haptic simulation, which is virtual reality, have shown very strong results in the development and other technical skills. That's why, to my mind, to optimize the teaching strategy for residents and to make safer surgeons, more expert surgeons, you need to mix physical simulation, which are actually cadaver, but which can meet ethical concerns and have limited anatomical supply to the surgeon, with virtual reality that provides quite a load of morphological, anatomical, and pathological variation, an unlimited use that you can use out of the OR in a safer environment with feedback, adaptive feedback, the data that you can exploit and provide to the trainee, an adaptive feedback to the procedure, saying you should work on that, you should develop that kind of ability of proficiency, and that's what I think is the more efficient. The final goal of that is to enable the surgeon to deal with every kind of situation. And it's an unpredictable game, the surgery, and you need to be the most prepared possible to face all this kind of possibility. Thanks.
Thank you very much, Nicolas. And we have put you here some references if you are interested to go further and to read more about the studies that has been shown and others showing the scientific validation on VR training impact for surgery. So now we will zoom into a specific industrial case and how virtual reality can be brought together with another kind of physical training platform, to meet the current constraints of surgical training. So I will let the floor to Nicolas Mignon to explain his vision and what the company Virtual Research is currently being developed.
Our inspiration came from the airplane simulator. We want to create a surgeon cockpit with a realistic immersion, multi-sensorial experience, and provide the virtual reality presence feeling as Hannah presented you before. The Virtual Research team is convinced that surgical training simulators must combine three technologies. First, virtual reality. Second, haptic technology. And third, data science. Now, I will show to you an example of training simulator using those three technologies combined that we developed for in Virtual Research for the company Diagnostic. In this video, you can see a virtual clinical room, a realistic patient with his bleeding coming from his nose, and a virtual mentor that guides the trainee during all the sessions. The proposal of this simulator is to train the HCPs in memorize the procedural step, learn the anatomical diversity, decision-making, analyze the disease, optimize the usage of the cavity, and evaluate the patient's pain. The training pathway provided by the virtual mentor was created with medical experts from Diagnostic company. Be a surgeon requires manual skills, dexterity, and precision. The medical or surgical instrument is an extension of the surgeon's hand. The surgeons must create automatism and reflex with their instruments. Now I will show you the cavity simulator developed for Diagnostic company. As you can see in this video, we designed a specific platform and we developed hands-on simulator using the real instrument. The real instrument is synchronized with virtual instrument. Doing that, we create digital twin of medical device. We use a haptic robot that allows a millimetric follow-up of cavity insertions in the nose and haptic feedback. And you can observe the perfect syringe synchronization between the real and the virtual world. Surgeons need a smart evaluation of their performance. In Virtual Research, we consider this feature as an important element for the educational approach. As you can see in this analytic dashboard, we define the most relevant metrics for evaluations in collaborations with the Diagnostic experts team. We provide the learning evaluations about the intranasal depth, the cavity orientations, and the patient's pain. We define strategic analysis to evaluate all the instrument trajectory during the training sessions. It is important to develop a scientific and pedagogical methodology to optimize the surgeon's assessment. The combination of those three technologies is the key to create very powerful simulator. However, we never forget that technologies need to be developed to serve the educational project. Immersive learning is really the cornerstone of Virtual Research ambition. Thank you for your attention.
Thank you very much, Nicolas, for giving us such a comprehensive overview of a concrete, tailor-made virtual reality training simulator. I hope the three presentations were very insightful to you. Thank you again to all of the speakers and for respecting the very tight timing of presentations. So now it's time for Q&A. So feel free to ask any questions you may have in the chat box and the dedicated space for questions and answers. And while you may be thinking on your question or start typing, I have a first question to ask the different speakers is on your experience and from what you are seeing, what will be for you the current trends and future of surgical training. So maybe I'll start with Anna. If you can share with us your insight on such aspects.
Yeah, so the future of training and education, especially now pushed with COVID, we can see that remote learning and how technology can support trainings that use it to be face-to-face. So that's a trend that we have now. And not only schools and universities are looking for that, but companies as well, because it can be scalable. It increases how many people you can put together at the same time. You can provide a standard training, so you're sure that all participants, they receive the same kind of training as well. So that's a trend that we have been figuring out right now.
Okay, great. Nicolas, do we have insight from the clinical aspect?
Yeah, on the data point of view, you can extract, well, it's actually under submission, it's my master's thesis work. You can extract surgical profile linked to cognitive skills and personality of the surgeon. I explain myself. In neurosurgery, for example, you have skull-based tumors with ORs that can last for 10 hours, 12, 14, 16 hours, and you need to have a personality with a lot of stamina and a lot of sustainable acting in the OR. Whereas there are other pathologies which are more shorter, but with very strong and accurate specific bimanual performances to provide. And from data of simulator, you can extract profile, which are not a mean to write destiny or fate or to predict the future of anyone, but to either to apply or to orientate the trainee to develop other skills to be more homogeneous, or to develop very strong points that the trainee has already to become much more efficient in this particular field. So we can orientate, help the trainee to develop himself, to become better in the OR.
Thank you. We have another question, which is very interesting, is what is the capacity for such kind of simulator and using virtual reality to address a wide variety of surgical indications and surgical fields, such as neurosurgery or cardiovascular surgery? Maybe I'll turn again to Nicolas from the clinical point of view.
On the cardiovascular surgery?
Yeah, and overall, if it's available for a wide kind of clinical applications.
Yes, specifically on the cardiovascular surgery, I've read few papers saying that this is one of the, in the cardio surgery, this is a field which is a bit late compared to other specialties, but which is actually developing itself. There's quite a lot of paper in open heart surgery and that kind of stuff in the last few months, which actually in the other specialty, it started with a general surgeon. It's a very famous US studies on celioscopy development, which proved very strong results on the efficiency of the procedure for cholecystectomy. And this was developed initially from that, but you can apply that to every kind of specialty: orthopedics, neurosurgery, ENT. There's a lot of endoscopic approach from the skull base or for ENT are very proximate, very on the technological point of view from the cavities that Nicolas showed us a bit earlier. It's very proximate on the technological point of view. So yes, everything is applicable to everything. There is no restriction on the technical point of view and on the cognitive point of view. If you work with a medical team and an IT team which is efficient, there is no limit at all.
Great, thank you very much.
And Yeah, I just would like to add to what Nicola just said, that the VR training for soft skills has been proven to be something really important in the medical area as well, because you can place this team together, and then you are gonna work with them, you know, communication, leadership, empathy, that are skills that used to be developed in an informal way during their training. And now we can use VR for that as well. And it has been showing very good results.
Yeah. And I actually have another question that is coming up for, and I think I would like to address it to you, is you talked a lot about the power of virtual reality and all of the great application, especially in the field of surgery. Can you tell us a little bit more on why do you think now is the good momentum for such VR application? Because VR has been around for some time now. And so what do you think in terms of the current traction, and why now is the good momentum to deploy such solution in a surgical setting?
Yeah, so now we have several aspects going on. For example, we have COVID that is requiring people to remote learning, to not be on the same physical environment. And VR is the best technology to provide simulations where you can feel that you are on that environment, but you are not there physically. So that's one thing. The other thing, we have been seeing the hardware costs is dropping. So we have good headsets now for a better price, consumer-based as well. And also we have a very good push on content development. So we have more content right now. And some years ago, if you would buy a headset and you could only use for just maybe 2 or 3 good content experiences, now you have more. So you can definitely integrate that more into the curriculum or the training program that you have.
Okay. Talking about deployment, I see another question coming up on how can we logistically distribute or set up such VR training solution directly to a hospital site. I don't know if Nicola, you want to talk about the mobility of the solution and how you envisage such kind of distribution?
In virtual research, we are very convinced that the future is the solution. So the future of the surgical and medical training is to be very near professional and physicians. So we develop solutions which with good mobility to be transported directly in the hospitals. It's very important to have this target, because we can find actually a lot of simulators, not VR simulators, like a 2D screen. They are very heavy, it's very expensive to move them. And we know with Nicolas Penet, with a lot of surgeons, that surgeons have less and less time to go outside to the hospital to train. So it's important the training come to the hospital.
And the use of VR headsets is very mobile, so it's a very good answer to such need. There's a lot of questions coming up. I think for the sake of time, I will only take 2 additions, and then of course we will come back to you to answer all of your other questions, and we stay at disposal for any follow-up discussions. So the first one is trying to maybe tell a little bit more on the scientific validation on such VR haptic systems. So maybe I'll turn first to Nicolas Penet on the overall literature, and then to Nicolas Mignon on the specific scientific validation that has been published on a VR haptic system.
This is a very interesting question. Depends upon what you want to say by validation. There are 4 levels of validation for a specific pedagogical device. If you want to validate the fact that before the use of the VR or the haptic system and after you're better in the VR, yes, it is. If you want to show that on a specific procedure in the OR, you're more efficient with a gain of efficiency and less complication. Yes, it is. If you want, as it is on a scientific point of view, as there are many studies about that I can transfer to you with pleasure. But if you want to prove that over the healthcare system, there is a gain, a general gain of efficiency or within the society, it's a level which is much too wide yet to be explored, to be validated. So it is validated on a micro scale, unipersonal scale, validated within the OR, yes, with the patients, yes, with less complication, but within the healthcare system, it's not enough diffused yet to be validated. And it's very hard to do the design of the study is very hard to do. What would be the endpoints to make a study, a proper study for that? But yes, it's going to be for sure, but never theoretically we will be able to demonstrate that you're better in the surgery becomes better with VR. I think it's like a virtual endpoint.
Nicolas, do you want to say something on a specific scientific project?
Yes. For the virtual research team, we have a lot of VR developers, but we have also researchers. People come from university, very famous. We have PhD, and this team wants to continue to develop a very good proof of the performance of the simulator we developed. So we have a roadmap for scientific publications about all the simulators we developed now, with the agreement of the company for which we produce them, to implement, to produce a lot of data about the training of the simulators, to follow the learning curve of the trainees, and to prove by scientific approach and good methodology and statistical methodology that we have very good solutions to train very faster.
Great. And I have a last question, so we can end up on time. Can you tell us, Nicolas, a little bit more on the actual regulation and the kind of classification of such VR training platform? Is it considered a medical device or not, typically?
No. The training solution in virtual reality we developed are not a medical device. We have no regulations, no regulatory for this moment. It's a chance in the world, actually. We have no rules very constrained to respect, because the solutions we develop are not used in the operating room, really in the real life. We are not on the diagnostic of the patients. We are not on the treatment. So we are just a solutions to help to train. So actually, we have no classifications to develop and to commercialize our solution.
Okay, thank you very much again for, I will keep the other questions for follow-up with each of you. I think it's important to finish on time, and we are right on time. Thank you again to all of the participants for your time and your interest into our such new digital education tools. I would like also to thank again all of the speakers for their interesting insights and their availability today. And we remain at disposal for follow-up discussions, and you will be able to review the webinar in a replay in the coming days. Thank you again for your time, and have a great end of day.